Welcome to the session 7 of Unit 1 in Digital Signal Processing. In this session, we will try to understand eigenvalue, eigenvector with the help of the numerical. Let us consider a 3 by 3 matrix as A equal to 8 minus 8 minus 2, 4 minus 3 minus 2, 3 minus 4 and 1. Let us consider the first part as part A to find the eigenvalues. Let us write the characteristic equation as A minus lambda I into x equal to 0, where A is a given matrix, lambda is a constant for time being, I is identity matrix, x is any unknown non-zero matrix, and 0 is the null matrix. Let us rewrite the characteristic equation in simplified form as mod of A minus lambda I equal to 0. That is, A I can write it as 8 minus 8 minus 2, 4 minus 3 minus 2, 3 minus 4, 1 minus lambda. I is an identity matrix, so as we have considered A as 3 by 3 matrix, we have to consider identity matrix also of 3 by 3. So it is 1 0 0 0 1 0 and 0 0 1 equal to 0. After simplifying this, what you can see is there exists only diagonal elements in the identity matrix. So 8 minus lambda into 1, that is 8 minus lambda, then minus 3 minus lambda into 1, so it is minus 3 minus lambda, and 1 minus lambda into 1, that is 1 minus lambda. So only these three diagonal elements will change, rest all elements will remain as it is. So what you can write is 8 minus lambda minus 8 minus 2, 4 minus 3 minus lambda minus 2, 3, 4, 1 minus lambda is equal to 0. If I solve this matrix, then I can get the equation as lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. Now if I solve this equation, I will get the values for lambda, that is lambda equal to 1, 2 and 3. So these values of lambdas are nothing but my eigenvalues. If I'm considering the matrix of 3 by 3, I will get 3 eigenvalues. If I consider the matrix of 4 by 4, I will get 4 eigenvalues. If I consider the matrix of n by n, I will get n eigenvalues. The same I have written here. I have just brought this matrix here for the quick reference. Now we have the second part, that is part B, to find the eigenvectors. Now we'll try to understand how to find out the eigenvectors for the given matrix. Actually, for each eigenvalue, we will have the corresponding eigenvector. Okay, so here we have the matrix of 3 by 3, so we have 3 eigenvalues. So for each eigenvalue, I have the corresponding eigenvector. So let's consider the case 1, that is first eigenvalue as lambda equal to 1. So for lambda equal to 1, we can write the characteristic equation once again with the lambda equal to 1 now. So characteristic equation is A minus lambda I into x equal to 0. So I can put all the values, I can put the matrix A as 8 minus 8 minus 2, 4 minus 3 minus 2, and 3 minus 4 minus 1, minus lambda I for the identity matrix 1 0 0 0 1 0 0 0 1 into x, that is x1 x2 x3 equal to 0 0, that is 0 0 0, that is the null matrix. Now you can further simplify it, so it is 8 minus lambda into 1. So it is 8 minus 1 because value of lambda is 1. So it is 8 minus 1, that is 7, minus 3 minus 1, it is minus 4, and 1 minus 1, it is 0. So only diagonal elements will change. Rest all elements will remain the same, that is minus 8 minus 2 minus 2, it is here minus 8 minus 2 minus 2, and so on. So only diagonal elements will get changed and it will get decreased by the value 1. So once I got this form, then I have to consider any two rows. Only care we have to take is those two rows should not cancel, should not get cancelled with each other by any mathematical operations. Okay, so here I will consider the first two rows, that is 7 minus 8 minus 2 and 4 minus 4 minus 2. So here we consider the first two rows. So I have to find out this x1, x2 and x3. So I can consider this x1 here, I can consider this x2 with negative sign, and I can consider this x3 here. If I'm considering x1, means this first column I can skip. What remains is 8 minus 2 and 4 minus 2. So 8 into minus 8 into minus 2, that is plus 16, minus 4 into minus 2, that is 8. So here, if it is x1, you have to skip this first column and you have to consider the second and third column. You can cross multiply it and you can write it here. If it is second one, that is x2, I have to skip this second column. I have to consider this first column and second column, third column, and I have to do the cross multiplication. So what I can write here is minus x2. So I have to skip this second column. 7 into minus 2, that is minus 14, minus 4 into minus 2, that is minus 8. So minus 8, that is plus 8. Now for the third x3, you have to skip this third column. You have to consider first and second column. So it is 7 into 4, it is minus 28, minus 4 into minus 8, that is minus 32. So minus of minus 32, that is plus 32. So further we can simplify as x1 upon 16 minus 8, that is 8, minus x2 upon minus 14 plus 8, that is minus 6, x3 upon minus 28 plus 32, that is 4. So what I got is x1 upon 8, this minus minus will become plus, so it is x2 upon 6 and x3 upon 4. So I can write as x1, that is the first eigenvector, as 8, this minus minus becomes plus, so it is 6 and 4. So I got here 8, 6, 4. You can simplify further as 4, 3, 2. So this is the first, or this is the eigenvector corresponding to the eigenvalue lambda equal to 1. Similarly, we can find out the eigenvectors for the other eigenvalues. So for the second eigenvalue, that is lambda equal to 2, we can follow the same process as that we have followed for the lambda equal to 1, and we can find out the eigenvector for that. So the eigenvector, after solving eigenvector for this lambda equal to 2, you can have is 3, 2, 1. So this is the eigenvector corresponding to the eigenvalue lambda equal to 2. Similarly, again for the third case, that is lambda equal to 3, you can apply the same process and you can find out the eigenvector for the eigenvalue lambda equal to 3. So that eigenvector is x3 equal to 2, 1, 1, and this is the eigenvector corresponding to the eigenvalue 3. So that's it for this session 7.